Welcome everyone, welcome to Third Stage Europe. My name's Stuart Robb, as Kyla said. I'm Vice President, and we started the European practice about just 18 months ago. That'll come from reading my notes, won't it? So we started the practice about 18 months ago. We've actually had quite phenomenal and unexpected growth given the challenges that we've had with COVID. We've got over 10 consultants now. We've got a whole raft of clients, and we do a variety of work, including some digital transformations, some selection and procurements, and some assurance and delivery management. So really pleased to be with you all today, and looking forward to going through and talking about frontier digital technologies. So share screen. Okay. So what you should be seeing shortly is my presentation and me just standing up by the side. Click to close the message. Hold on, just give me 2 seconds. Hover here to hide. There we go. Right, good. Oh, hover here to hide. Click to close. Go away. Right, excellent. Okay, I can have some cover. So the first thing to say was that there was a very slight mistake in this. You can see that I was testing out the pen and I actually drew on my own diagram and I can't get it off now. So forgive me for that. Hopefully it's not on the real one. So let's just get the intros done and then we'll get into it. Oh, hold on. A little bit too sensitive for me, I think. Try that. No, that's not going to work. Ah, come on, give me a break. The technology is not working. You were right, Eric. Give me a break and I'll go from the beginning again. Right. Display settings. Okay, we'll do it with the mouse. Okay, now that's what comes if you rely on PowerPoint rather than using a proper studio gallery, but there we are, automation not fully working for me at the moment. So let's move quickly on. So just a quick sort of little bit about terminology. I didn't make this terminology up. In fact, this is what you can get off of Wiki. So I don't think you'll find it sort of to be too extraordinary. You can read these for yourselves, you don't need me to, but the RPA that we talk about today is what we used to call screen scraping in the 1990s. It's more sophisticated, yes. Does it do a bit more in terms of AI? Yes. But, you know, to a very large extent, the RPA software captures what is going on a screen, monitors what the user is doing, and then repeats those tasks over and over again. So it's a sort of, I think you call it intelligent screen scraping. Artificial intelligence. So human speech is probably the one that most people talk about. Self-driving cars, what we're seeing now with Amazon around drone-based delivery, all of that could be described as artificial intelligence. Or could it? We'll talk about that in a minute. And then digital ledgers, also known as DLT, is basically a way of creating tokens that create blocks of data with effectively a key, cryptographic key. And so if you have produced this one and this one and this one and this one, and then you change this one, then all of the rest of the blocks will therefore error. So it's a way of confirming that a particular transaction or a piece of data is as it was when it was originally created. And that's why it's useful in applications like Bitcoin, and also in, I don't know whoever made this term up, non-fungible tokens, NFTs. And you'll see on the right, there's a $6 million sale of a piece of digital artwork from Elon Musk's, I'm not sure if he's his wife or his girlfriend, but nonetheless, that's one of the most obvious new examples of NFT. So what you're getting there is a digital certificate. Again, in the blockchain, that digital certificate is perfect, because if that digital certificate is interfered with, then that and all the subsequent certificates will then error. So it is a strong way of guaranteeing a piece of data. And so blockchain, which is part of this DLT, each block has a list of records. It could be certificates, it could be payments. They link, as I said, they're linked in cryptography. They have a cryptographic key and a hash, a timestamp, and obviously the transaction data, because that block is perfect. If it's changed, then all the subsequent blocks will then be altered retrospectively. And so it's a very good way of guaranteeing data has arrived securely. Now we'll talk a little bit about what the use cases for that are in a minute, but that's kind of where we start from. So why would you want to use frontier? So why do I call it frontier technology as well? Because I think it's a little bit more like the Wild West. Obviously, I know that a lot of organizations call it emerging technologies. I tend to think of it a bit further than that. If we were emerging, we'd be emerging from New York. If we're on the frontier, we're way out in, the wilds of Mexico and California. But we're talking about the same things that we always talk about in business. We're talking about competitive advantage. We're talking about time to market. We're talking about improving revenue or reducing cost. We're talking about improving customer services, and we're talking about security and GRC, governance, risk, and compliance. And it doesn't matter that whether you are a company that was in the 1970s, or a company that exists today. Most businesses don't care about the technology per se. They just care about the results from using the technology. Now, that's not true of every organization. Obviously, Amazon is a very technology-based company, and you can argue that there are companies out there that are similar. But most businesses, when they are generally servicing their customers, don't like to or want to be technology companies. They want to utilize technology to get results. So they will hedge their risks, and that you try as far as possible to avoid failure. And so the evaluation that you're making is where you come on the adoption scale. Are you going to be an early adopter of new technology, which may potentially fail and you'll end up, with nothing to show for it? Or are you going to be a late adopter when everybody else has already got all of the competitive advantage? And those are the age-old questions, and they haven't changed, in probably the past 50 years. In 2011, I mean, that's 10 years ago now, Watson won a edition of Jeopardy. And it beat two Jeopardy champions. And what was interesting was that when this was written up at the time, people used Watson in the human context. He played the game like his human counterparts, not it played the game like its human counterparts. And so the question really is that intelligence? And it's an age-old question. What is artificial intelligence, and when does that compare with real intelligence that you could argue some of us, maybe not everyone, displays and enjoys? And if you look at the definition, well, the capacity for logic, clearly the Watson had the capacity for logic, for understanding, for learning, for reasoning, for planning, for creativity, critical thinking. It showed all of those when it was playing Jeopardy. Now, whether it was self-aware and what its emotional knowledge was, I think is probably more open to question. So if you'd asked Watson, what are you doing? It may well have replied, I'm playing Jeopardy, but it will have done that programmatically rather than because it was watching itself on the television. And so how far does intelligence go in artificial intelligence? Well, computers are very good at algorithmic reasoning, but they are not very good at judgments. And they're certainly not very good at making a cup of tea. And it also seems that they're not very good at driving cars, although the jury's out on whether or not the two unfortunate gentlemen who decided to sit in the back seat and the passenger seat and let the Tesla drive home actually had it in fully autonomous mode or not. So here are some examples. These are what I call kind of current state examples. So on the left-hand side is a chat box, and most of you will be aware of chatbots technology. And you can see there, this is UPS. I said, how do I pay my customs charges? Now, this is actually a real example. I did do this about 2 or 3 months ago. And what happened was I got a nice explanation of click on the pay it now, locate the attention needed, except when I did that, it didn't work. It wouldn't allow me to pay it, just return to the same screen again. So then I asked the question, what do I do now? It's just return the same screen. And obviously it totally and utterly failed because it has no deductive reasoning and it has no critical thinking. It was merely parroting answers that it had seen that were successful answers before and repeating those back to me. Now, what's very interesting, you say, oh yeah, that's really, really clever. But the problem with it is that it has no actual intelligence. Its database is only as good as the questions that have been asked and successfully answered. So the question is that artificial intelligence? Now, I'm a fairly old kind of chap, and in about 1972, I went to the Science Museum, and they had a demonstration of a computer there. And you could go up to it, and it had a teletype, and it had a game on it called What Am I? And the premise of the game was that you asked it a question, or it asked you a question. Oh yeah, so it said, think of an animal. And you'd say, okay. And then it would say, does the animal have 4 legs? And you'd say, yes. And then it would say, is the animal a dog? And you'd say, no. And it would go, I can't guess what your animal is. What is your animal? And you'd say, it's a cat. And then it would say, what is it that differentiates a dog from a cat? And you'd say, a cat has pointy ears. And now when you ran the game again, it would remember the answer to your question, and it would then go through the same cycle again. Has your animal got 4 legs? Yes, it has. Has your animal got pointy ears? Yes, it has. Your animal is a cat. Now, is that machine learning? Yes, it is, but it was being done in 1972. This is not something that we did last week. Okay, is it sophisticated machine learning? Well, probably not. But computers today still, if you give them an image of a dog or a cat, they still struggle to decide whether the image is of a dog or a cat. So, you know, we say we've come a long way in these frontier technologies, and yet, you know, a hard critical eye on some of them, maybe we haven't come quite as far as we think. So there's another great quote. Oh, sorry, no, the one on the right-hand side is around invoice automation and OCR. Now, what's interesting is that when I was looking at this, it was said that OCR is no longer generally accepted as AI, and its use is now ubiquitous. And they described that as the AI effect. And the AI effect is basically that you discount anything that is labeled as AI, by arguing that it's not real intelligence because everybody's using it. So I'm not actually sure that even when we're using the term AI, we really know precisely what we're describing. But what I found most interesting was that when I was doing my research on this, you look at this piece of technology. This piece of technology was developed in about 1996, 97. And you can see it's Windows 3.1. And so again, to say that invoice automation and OCR is brand new and everybody's getting very excited about it is probably a bit of a misnomer. Yes, it looks horrible, I agree, and yes, it probably didn't work very well at that, I certainly agree, but nonetheless, the embryo of that technology, predates what we would generally consider to be exciting AI by probably 15 years. And in fact, even when you look at some of the new RPA and AI tools, these happen to be screenshots of UiPath, which is a well-known RPA tool, very good. Then even then, it doesn't strike us as having gone a long way from between there and there. So the OCR is better, the automation is better, the recognition is better, but these are slower steps than I think people generally realize. And the other thing, of course, about that is that these are all business tools. And so, the progress of business tools tends to be more evolutionary simply because of business reticence to get excited about them and roll them out. Are they intelligent? Honestly, I wouldn't have described these as intelligent. There's a great quote in the film I, Robot. Can you write a poetry or compose a symphony? Asks the detective. And the robot turns around and says, no, can you? So I think, we are excited about AI and we should be excited about it, but I still think we're a bit of a way away from it. Now, this is a diagram from Accenture. I usually steer clear of diagrams from Accenture because they tend to be a bit complex, but I quite liked this one. And so there are some things on here which I think are useful and that we can pick out. So first of all is, migration to the SaaS. Well, obviously we're already doing that. On-demand self-service reporting, that's very keenly done at the moment, and companies continue to try to make strides in doing more in self-service reporting. And then robotic process automation, screen scraping, repetitive processes is something that we've talked about already. And then you start to go into what they call scaling. And, we are seeing EPM tooling, doing scenario modeling, so PBCS or JEDOX or artificial insights or any one of those. We are getting centralized transaction level data. Well, yeah, we are, but we had that in 1979. It was called KICS and it ran on an IBM mainframe. So again, I'm not sure that I think that really qualifies as emerging technology. And then in-memory computing, so anyone who's had the fortune or otherwise of sitting through a SAP presentation will know that is all that they talk about is how wonderful S/4HANA is for its in-memory computing. And as far as I can tell, what that means is it's got computers with an awful lot of memory that can contain the entire database, whether it's SSD or relegate. So is that exciting? No, I don't actually think it really is. I don't think it's any more exciting than cash was when it was invented back in the late 80s and early 90s. And then also on this other track, we've talked a little bit about AI and machine learning. Machine learning and AI, I still think, is very embryonic. I think powered statistical forecasting is definitely advancing. That's probably advancing quicker than a lot of these. And we're now starting to see predictive analytics coming into play. and the use cases for that, for airlines, for engines and things like that is quite obvious. But then when we get over here, you know, we really start to struggle to see good use cases. We see Bitcoin as the ubiquitous blockchain, and now, you know, some artists are selling a few pictures using NFT. But really, if you try to list the number of blockchain systems, you'd find them mostly in financial services around, for example, payment systems and things like that. Really, outside of that small circle and that small window, there isn't a huge amount of use cases that you can latch onto and go, that's a good idea. Just going to check to see if we've got any questions. Yeah, no, it doesn't look like we have. That's fine. Right. So what this says is, at the moment, the probably the most common use case, excuse me, for emerging technology is chatbots, and as I said, I think they still have their limitations, quite frankly. Where you start, where you think you might be using frontier technology, it's quite often that actually you're not. So, for example, airline pricing is actually still done by price bands, by dates to flight, by flight popularity, by seat number, and there are various things that go to inform the price of your ticket, but it is not currently, for at least a number of the British airlines, a wonderful Whopper style artificial intelligence engine that sits there and calculates the price. It's basically a bunch of people putting criteria into a model, and that model spitting out a price at the end of it. So is the model intelligent? I'm not sure. I think it is. The credit scoring. So again, most credit scoring is still done on a fixed algorithm. Do I have 2 children? Have I lived at my property for more than 3 years? Have I gone bankrupt? You know, they are fixed algorithms. They don't learn yet whether or not you should be eligible for a loan because people who are similar to you have gone, have defaulted. And we still don't see very many examples of where credit scoring has started to become much more sophisticated than it's been for the last 30 or 40 years. And even on aircraft engines is probably the most advanced. There's definitely a move from preventive maintenance to predictive maintenance. And I know that Rolls-Royce and a number of others are trying to move quite fast in getting to a predictive maintenance so that they've got parts replaced and on site at the right time to prevent a failure before something even starts going wrong, and using the analytics that they have and the tooling that they have to analyze the data and see what is most likely to happen at any point in time. We've talked about call centers and chatbots, and the other area that we are seeing frontier technologies is in AP and AR, accounts receivable and accounts payable, and we'll talk a little bit about those in a second or two. So if you're going to adopt frontier technology, really you've got to trust it. And trust comes from a number of places. It comes from other people's successes. It comes from imagination and innovation to be able to apply the new technology to a particular business problem you have. And some use cases will be further ahead than others. So obviously we know about autonomous vehicles. Quite honestly, I would never sit in a vehicle that said it was fully autonomous, especially not in the snow. Facial recognition comes with its own problems, and we'll talk about that in a minute. You've got the whole IoT industry 4.0. And one of the areas that actually is quite interesting is that there's quite a lot of work going on in farm to tech. We have a client in Europe, in France actually, and the US that are getting quite heavily involved in that, and looking at what the the possibilities are, particularly in the areas of fertilizer and pest management, in tech to actually automate the farm machinery rather than having it physically operated. So there's a number of kind of places in there that's starting to look quite exciting. So all down the left-hand side, no, that's the right-hand side. I've got to try and work out which way you are. All down that side are traditional technologies, okay? And I would say that most of them, even in their suite apps or their app suites, don't tend to have anything to offer or much to offer in the frontier technology space. I would say probably the exception to that would be S/4HANA. And I think Oracle are doing a bit in that space. In fact, Oracle are doing quite a lot. But in terms of the business suite and the cloud apps, there's not a lot there that you could hang on to yet. And then N4 have been buying heavily, and they are starting to use your AI, in some of their products. So the emerging ones, there are a few names that you may not recognize, like Cabina or H2O or Digital Genius. And then there are ones that you may well recognize, like Proactive's High Radius Blackline. And what you're starting to see is that some of these traditional technologies are now starting to leverage AI more. For example, Blackline are developing or have developed AI to do transaction mapping, particularly where FX rates don't completely align. High Radius are doing a lot of work in using artificial intelligence to identify bad payers in advance and take corrective action early, and that's very interesting. And actually, we're supporting clients both in the US and in Europe on some of these technologies, particularly the four here. Infor also are making, as I said, investments in emerging. Their demand management, which is an area that's actually quite obvious for machine learning and artificial intelligence. They've made quite a big play of that, and actually that's proving quite successful for them in predicting demand and therefore matching supply. This is Cabina. This is a very traditional, this is RPA. You'll see that this really, honestly, doesn't look a huge amount different from the lead stream one that was Windows 3.1 that I showed you earlier. But it is faster, better, more refined, less error rates. So this is RPA, but you could say that, you know, we have come a long way in RPA, and it's now something that you can sort of rely on more rather than not. Now, okay, there's a fair bit in this, so I'm going to try and walk through it fairly slowly. So within the context of frontier technology and artificial intelligence, probably the best known is called fuzzy logic. I remember about 10 years ago, or maybe actually it might be a bit more than that, I'm getting a bit old now, 15 or so, somebody told me that my washing machine had fuzzy logic in it, and I kind of expected my my shirts to come out all fuzzy and my sweatshirts, which in some cases they did. But the idea of fuzzy logic is quite simply to take imprecise data and make an assumption based on data that's not either yes or no. So a good example of that is the question, is it cold? And rather than it just being simple yes or no, there are various weightings or truths, as they call them, that you can put on that data to say, well, it's not really cold or it's very cold. And it will build a picture up that will allow a decision to be made at the end of it. Now, fuzzy logic is still used in a lot of algorithms today. It's fairly widely deployed, and so there's not a lot to and a lot more to say on that. Where it starts to get more interesting, ANN is called artificial neural networks. And the idea here is that the algorithms are acting on data using inference and reasoning rather than just adding a value to a piece of data and then, scoring that data based on its weighting. So most of the models in artificial neural networks are statistical models, but they're not on linear relationships. So a good example of that would be a mortgage fraud application. Again, in the 1990s, I worked on a product called Anthesis. And Anthesis was a product that identified links between data. And it would look at a database, in those days a mainframe database, and it would identify any strong links between data that it saw. So you would give it a hypothesis. So you would say, my hypothesis is that you can find a link between the mortgage applicant, the estate agent, and the solicitor. And it would go and it would look at the data, and every time it found a link, it would display that on the output. And what it would do was create, you'd be able to see immediately that there was a solicitor, an estate agent, and a mortgagee that had a very, very thick line, whereas most of the other lines were all very random. And when you looked at that thick line, there was a significant number of mortgage fraud applications related to those three partners. And that would have been impossible to have identified that by doing a data search. It was only once you saw it visually using a neural network that you could actually do that. And having, again, it was self-improving, not the ones back then, but they're self-improving. So as they develop better knowledge and they get better understanding about the successes, that in the same way that the brain does, reinforces that neural pathway and starts to retire other ones that aren't as important. The biggest problem, I think, in the take-up with artificial intelligence will come. It's probably not there quite yet, but we are seeing examples now of where ethics are starting to play in AI. I attended, I think it was early last year, a conference on the ethics of AI. In fact, the UK government are taking a great interest in this. There are some papers published, and some of our politicians are actually quite concerned about it and are already looking at how you legislate AI. And I guess the same is true of other jurisdictions. And the first area of concern is around what they call AI biased. And the bias comes from the fact that it can come from two places. Firstly, the intelligence is prejudiced in some way because of a prejudice in the algorithm. But actually more common is a prejudice in the data called the curation process, when the algorithm is initially learning. And a very well documented example was in relating to race and color, where the prejudice was biased towards Caucasian, for the simple reason that the university input data had predominantly come from white Caucasians, and actually white Caucasian males, not even females. So the data set was prejudiced in the initial learning, and that tainted all of the subsequent data capture and the learning algorithm that came behind it. So again, you'd have to be very, very careful and make sure you've got a very, very balanced initial learning data set in order not to prejudice your AI. The second issue is what we call a kind of unexplainable outcomes. And that comes from the fact that most organizations that try to implement AI tend to try to implement algorithms that are too complex. And again, so, we're all used to applying for a credit card or a loan and the computer says no, and you'll never get an explanation out of the bank as to why it's turned you down. But in other instances, that could become quite a problem. And actually, as the algorithms become more complex, once the algorithm gets out of control, even the people who created the algorithm can't explain why it's making certain decisions. So an example of that would be, if I was applying for a loan of, let's say, £25,000 on an unsecured basis, and I accidentally typed £250,000, and the computer says yes. Now, it might have said yes for a very good reason, or it might have said yes because it's a bug. But unless you understand how it's come to that conclusion and what the algorithm was behind it, you'll never be able to understand why it suddenly decided that in my special circumstance, it should give me a loan that's 10 times greater than it's given anyone else. So that's the unexplainable outcomes, and that's also a big danger, and especially a danger in a regulated business, because if you go under investigation, for instance, in financial services, and you can't explain to a regulator how a computer has arrived at a decision, then you're in trouble. And there's one other thing on that, of course, which is that the computer has no sense of humor and no personality. So the likelihood that it gave me a £250,000 loan just because it was bored is probably not going to have happened, but who knows. Then the third area that gets quite a lot of attention is facial recognition. Now, there was a film a few years ago called Minority Report, science fiction film, and it used the eye retina. And as you walked past the scanner, it would scan your eye retina and see who you were, and then offer you a personalized offer as you walked past a screen in a department store. Well, they got that slightly wrong, because actually it's not the retina, it's your mobile phone IMEI signal that it uses. And there aren't any department stores, or at least there are very few left because of Amazon and everything else. But in the context of direct personalized marketing using facial recognition or anything similar, the regulators again have got quite exercised about making sure that people's privacy are protected, and that they've got proper authorization to do that kind of marketing. Now, the area that actually gets even worse is in law enforcement, because obviously law enforcers love the idea that you can recognize a face, but actually in the test, only about one face it actually only successfully recognized about one face in 80. So it's still pretty poor in terms of its success rate. And it's created all sorts of issues with people saying, I don't want to be in front of a camera being recognized. It's invading my personal privacy. And there have been a few court cases in this country, certainly in the UK, over that, and the jury is still out as to how that will unfold. And then obviously there's direct personalized marketing through social media. And again, politicians in this country, and I think also possibly politicians in the US and other jurisdictions, have got quite exercised over organizations like Cambridge Analytica doing intense data analytics and adaptive marketing in order to target political messages to micro groups to reinforce their message. There are now some regulations in this country and in Europe actually to stop that happening. And I know in the US it's a little bit different, but certainly the idea that you can micro target individuals to persuade them to your point of view, is that ethical? And I'm not making a judgment on that. I'm just saying that is a fact. That is what can be done. And so, we need to be mindful of that and take that as you find it. So, kind of finally for me, and then we can kind of throw it open in the remaining time. There's something called the solo paradox. It's also known as the productivity paradox, and it's a measure of IT investment versus improvements in productivity. And in the 1970s, paradoxically, as more and more IT was introduced and more automation was introduced, productivity actually went down. And it continued to do that for the best part of 2 decades. Now, in the 1990s, there was a big transfer of capability from green screens to personal PCs using Windows. And actually, again, what we found was that, I remember actually being in a utility that did this, you found that the people who used the green screens, they memorized all of the quick codes, and they were able to tab to the place they needed on the screen very, very, very quickly, because it's something that they had muscle memory for, and they did in and out every single day. And then when we replaced those with Windows technology, where you had to accelerate a mouse, move it to a particular location, decelerate, stop, click on the button at the right for the down arrow, get the drop down, and pick the field that you wanted, actually is slower, and it's slower by quite a significant percentage. And therefore, call centers that implemented this new wonderful technology, particularly during that transitional period of going for green screens to early adoption of PC technology or Windows technology, actually found productivity went down and fell off a cliff. And it took a long time for that productivity to recover, to the extent that most software providers now always provide quick codes. So, for example, Infor, you don't have to use all of the drop downs and the clicks. You can type the code for the program you want to go to straight in, and it'll jump you straight there. So we are seeing a re-emergence of this productivity paradox, and the reason we're seeing that now is, again, because we're starting to introduce technology without really understanding what the impact is going to be on the organization, and thinking through how people are going to react and interact with that, particularly from an internal colleague perspective in businesses. So we also see General Motors and Tesla. Tesla had to learn again the same problem that General Motors had had some years earlier, where in fact Tesla over-automated their production line and had a huge number of problems. A good example of that is installing a dashboard, which needs a bit of ability to jiggle it about and wobble it and move it, which is actually much better done by humans. And in fact, Tesla had to learn that lesson. In fact, took a lot of automation out of their factories, simply because it just wasn't as efficient as getting a human being to do it. The second issue is obviously the labor demand. We've had 100 years of the tech is stealing my jobs. In fact, actually, we've had a lot more than 100 years of the tech is stealing my jobs. Anyone who knows about the story of the people who wore clogs and the looms, the clogs were called sabots, and they took the clogs and they threw them into the looms to stop them working, hence the term sabotage. Anyone who knows the film, the Star Trek film, will know exactly where that comes from. But actually, that's true, and we had the same thing in Britain around about the same time, in sort of the late 18th century, was called the Luddites, and the Tolpuddle Martyrs, I think it was as well. I'm sure if I remember that correctly. But nonetheless, people are naturally very nervous of computers taking over jobs, and particularly where the computer takes over the job and makes the job that the human is left doing less rewarding than it was before. And again, there are some OCM impacts that companies often don't think through fully enough. Think about exactly what that impact is going to be. The third thing is on the liability risks, and the most obvious immediate example of that is the tragedy that happened with the 737 MAX. Most people will know that Airbuses are pretty heavily automated. The same is true now, the 737 MAX. And the reason for the problem with the 737 was that, unlike an Airbus that actually sits quite a lot higher on the ground, the Boeing sit actually quite low, and so their engines are pushed quite far forward. And so on the MAX, they needed a bigger circumference of the engine, so they needed to push the engine further forward in order to create enough clearance in front of the wing, in order for the engine to sit. And what happened was that pushed the center of gravity and the turning moment forward, and so the plane would effectively go into a stall much quicker. And so what they did was they put some software in to force the trim on the elevators down, to push the nose down. Now, the problem with that was that there was only one sensor. It was an optional extra to have the second sensor. I mean, God, the sensor must have been $10, right? But nonetheless, the problem was that if the sensor failed, it would push the nose down, even though the plane was in level flight, because it didn't have any knowledge of what the attitude of the aircraft was. And the consequence was that the aircraft just descended into the deck. Now, the humans couldn't overrule it. In fact, they could overrule it, but the procedure to overrule it was so complex, and the amount of training that they gave didn't actually allow the pilots to know how to do it in most cases, that the tragedy was almost inevitable. And what's interesting is that Airbus had a similar problem some years earlier. And in fact, a friend of mine who's a training captain, EasyJet, said that they introduced a procedure whereby there are they introduced two circuit breakers, and you could turn all of the automation in an Airbus off. It's very secret about which two it is, but you can turn all the automation in an Airbus off and turn it into a Cessna. And if everything goes to hell and you really lost the plot on what's going on, you turn the procedure now apparently is you turn the circuit breakers off, all the computers go off, raise the nose, push the power, and hopefully up you go. So we were obviously doing a flying lesson, but I just thought that was interesting. God knows how much that would have cost Boeing if those two tragedies had happened in the United States, in Washington and Los Angeles, as opposed to Indonesia and Africa. The second to last one is around the security risks. And, I put iRobot in the Terminator series. I think we are a long way away from that, but the ethics around using military autonomous technology for the purposes of warfare, so drones that will decide themselves whether to shoot, robots or tanks that will autonomously decide whether to open fire, is a massive danger. And I know that certainly organizations, for example, Boston Dynamics, are doing a lot of kind of work in that area. But the problem with this kind of security risk, particularly in warfare, is it creates the environment where the winner of the war is going to be the person or the country that can churn out the most of these autonomous robots, not the number of humans involved in the war. So that'll be an interesting 22nd century problem if we ever get there. And then finally, and sort of to wrap up what I was going to say, there's my favorite story, which is about the Christmas trees procurement. So this is a bit apocryphal, but all of these come from the embryo of truth. And a government department put in an automated procurement system, and it told the system they wanted to buy Christmas trees for the entire department, and the department's based, across a number of locations. And so they gave it the task of buy the Christmas trees, and it didn't buy any. The first year it bought some, and that all worked fine. The second year it didn't buy any, and it went on and on and on, and they got to about the 17th, and there was still no Christmas trees. So departments eventually started ordering for themselves, and Christmas came and went. And then on about January the 12th or the 15th, all of a sudden, departments started getting hundreds of Christmas trees shipped. Why? Because the algorithm had determined that Christmas trees were a lot cheaper to buy in January than they were in December, and so it went and bought the Christmas trees in January. And that's my apocryphal little AI procurement story. So, okay, so hopefully you found all of that a little bit interesting. Let's see if we can do the next thing. Okay, and I'm willing and happy to take some, to take some questions. And I'm looking at my screen, and there aren't any. So if anybody has any, now's the time. Or Kyla, if you can moderate.
You bet. Looks like we have one from Christina. She was asking about text analytics, so such as predicting office successive scripts, predicting fashion trends, identifying business problems through the text of customers, and then voice stress detection of CEO earnings call. So she had questions about those.
Okay. So let me deal with the voice stress detection one first. So yes, there are algorithms in systems that claim they can detect voice stress. This was trialed in the UK at the Department of Work and Pensions not long ago, about a year ago. And what it was doing was looking for voice stress in the applicants. So if it detected voice stress when they were answering whether they'd got 60 million quid in the bank or whether they really needed a food bank, it would reject the application. Now, what actually happened was that there was such a furore and uproar about the fact that this technology was being used, and nobody had known about it until a whistleblower let the cat out of the bag, that the trial had to cease. The results of that trial were interestingly inconclusive. They really didn't get any better idea of whether or not it was detecting at a higher rate than could ordinarily have just been detected by the existing techniques. And we think partly that's because the technology didn't have enough time to get any realistic results. But people could be stressed for a lot of different reasons, and that's, I think, where the risk is, because I could be stressed because I'm lying, or I could be stressed because I'm nervous, or I could be stressed because I've just had a row with my wife. And, all of those things can come into play when you're having a conversation. And what's most interesting is, and I think the biggest militation against voice stress detection is that humans tend to infer based on not only what they hear, but what they see. So if there is a demeanor of nervousness and there is stress in the voice, then they will interpret that to be, somebody's got something to hide, or when you're going through security in the airport, they'll pick you out because they don't like the way you look. Whereas if you take the visual element out of it, you use one of the components that contextualizes the validity of the stress analysis. So it has been tried. I'm not completely convinced. I think it's a tool that can be useful to help augment, but I think it's a very dangerous idea to use it as a tool to decide. Okay, the second half of the question, sorry, could you give me that to me again, Kyla?
Yep, absolutely. So we're talking about text predictions through
Yeah.
analytics.
Yeah. That's not something that I've had a great deal of experience of. And that's quite embarrassing, actually, because the guy who used to live around the corner from me was actually worked for a company that did that. And I do know of companies that use open text for textual analysis and what you call it, contextualized storage, so highly indexed storage of handwriting. Again, I don't know a huge amount about this. I did the last conversation I had with it was that it's pretty good at recognizing most people's writing and wouldn't have a chance in hell of recognizing mine because it's such a scrawl and a scribble. But being serious, no, it's not a subject I personally know a great deal about, so I'd prefer to sort of park that question.
Yeah, no problem. So in the questions, folks, if you do have experience with text analytics, feel free to comment on Christina's question as well. So we can do a few more here, unless Eric, you want to talk about text analytics, or we can go into just a few more of these.
There's one here on the chat, which is predictive analytics for construction related to health and safety. No, again, Mark, that's not something that I've come across yet. It's certainly something I should have found out about soon. But again, if you've got any experience of that, just drop a few notes in the chat, and we can sort of look into that more deeply.
Yeah, and then Richard had a question too regarding distributive ledgers as well.
Well, as I said, distributed ledgers are almost like the higher level technology, and blockchain is an example of a distributed ledger. NFT, digital certification. I think identity management will end up being something that's done using distributed ledgers. That's a classic use case for it. Other than that, no, it's kind of like I said on the call, sorry, in the presentation earlier. It's some of these are really great, ideas, but actually the creativity comes in turning them into something tangible and something that you can actually use, and that is definitely one I think is a bit bereft of. It's a problem looking for a bit of a solution.
Excellent. Well, if you don't mind, Stuart, just dropping your contact information in the chat box, so if anyone has any additional questions. But thank you so much. This was a really interesting presentation and a lot of great information on things that are coming down the road in the future.